So thanks for being here. My name is Brandy Julian. I am the training manager with Craftco. This handsome gentleman to my right is Brian Darling. He is our Western Regional Manager, Sales Manager. All right, so here's the things I'm going to start off with. We're going to talk about crack treatments, what's crack sealing, what's crack filling. Who here knows what the difference is? Is there a difference? Who says yes? Show hands. Who says it's different? Who says no? Same thing. Show hands. Who says no? No brave ones? All right, you're right. They are different. Yes, they are different. We're going to talk about what those differences are. There are a lot of studies out there that have been conducted. They've done some surveys and questionnaires for folks. And in most instances, the data shows us that most people do not see a difference or don't know what the difference is. So we'll spend a little bit of time here with just some of the basics explaining what those differences are. We'll get into some of the benefits and why you would crack seal or crack fill. And then I'm going to talk about some pre-treatment information that we have. So these are, so crack treatments, it's crack sealing, crack filling. I already talked about that a little bit, and that yes, they are different. But ultimately, crack treatments, they've done a bunch of studies on it. It is proven this is the most cost-effective pavement preservation method that's out there. All right, dollar for dollar, you get the most benefit per the dollars spent in crack treatments. Okay. So the difference between sealing and filling. Now this text that's up here, this is from FHWA and their definition of crack treatments, filling and sealing. And you'll see I've underlined a couple of the words there. That's where the main differences are. So crack sealing is considered to be placing specialized materials into and above cracks using configurations to prevent the intrusion of water, debris, etc. Filling is considered to be placing ordinary materials. So we have specialized, ordinary, and then we have preventing infiltration versus just reducing the infiltration of water into a crack, right? Okay. So ultimately, why are we crack sealing? What are you trying to do? Keep the water out? Because what are you trying to protect? The base, right? Exactly. It's not the driving surface, right, that we're worried about. We want to protect we want to keep the integrity of that base and those sub-base layers, keep that pavement in good condition. So we want to keep the good roads in good condition. So sealing, again, is defined as specialized materials that will prevent infiltration into your cracks, where filling is considered going to be the placement of ordinary materials that just kind of reduce the amount of water that can get down into those voids inside of those cracks. This chart here, can you see this in the back? I know it might be pretty small. I do know that they are going to be sending out all of these slides, though, to everybody at the end of the conference. So you will have all of this data at a later time. I see you taking pictures in the back. So if you can't see it very well, you will get this data. So over here, this is kind of the crack sealing column versus crack filling. And these are just a comparison of some of the differences, again, just to help you get a greater understanding of what those differences are. On the crack sealing side, we're saying it's completely preventing infiltration, where filling is just going to reduce specialized versus ordinary. Crack sealing materials are specialized because they are engineered products, right? We're looking to get different types of properties to have high temperature stability and low temperature flexibility or elongation with a sealant. It's engineered, it's a specialized material. So we want sealants to be elastic and flexible, right? We don't want them to track at really high temperatures, and we don't want it to crack open at really low temperatures. On the inverse, crack fillers tend to be rigid, semi-rigid materials, can't really endure like any of those high moving transverse cracks. We know that they're not going to be able to accommodate that movement in that crack that's anticipated, where crack sealants can. You want to use a good quality sealant, especially where you're anticipating a lot of movement in the cracking that you have. Sealants typically, we'll talk through placement configurations later. Who does, what type of work do you do when you crack fill, crack seal, whatever you call it? Blow and go, who routes? What do you guys do? Blow and go. Who here routes? Show hands, who routes? We have one router in the room. One router. Do you route everything, or are you just hitting moving stuff? What do you typically route?
We've been doing everything.
Doing it all? Okay. All right. So we do know that with sealant, if you are getting a high moving crack, and we'll get into that, I'm getting a little ahead of myself, but you definitely want a high quality material that's going to be able to accommodate that movement. And studies have shown, we know that when you route, you're going to get better sealant performance. And we'll go into that later, and Brian will touch on that too in the best practices for installation. Considered semi-permanent for crack sealing, 3 to 5 years is kind of the average standard we see in testing and performance of that material. That's of the sealant material, right? Crack fillers, we typically see a couple of months up to a year. We know it's a temporary fix. Again, life of it is a few months to a year. If you're sealing and overbanding, so if you're doing your blow and go, or if you're routing and sealing, you're going to get 2 to 5 years, and studies have shown up to 7 to 10 years of sealant performance in newer pavements when you're routing. Okay. Some of the differences in the materials. So again, when you're sealing, you're looking at a specialized material versus an ordinary material when you're talking crack filler. So here's some of the differences on the sealant side. You're looking at your ARs, your asphalt rubbers, the rubberized asphalts. This is when you're getting into your spec material, your D6690 type 1, 2, 3, and 4 materials, your low moduluses, all of your sealants that are going to have polymer inside of them, etc. They're specialized, they're engineered products. On the filler side, you're seeing more of your ACs, cutbacks, emulsions, fiberized asphalt. If you just do sand and oil type applications, or just oil and sanding over top of it, okay? Does that make sense to everybody? Understand the differences there in a nutshell? Yep. Okay. All right, moving on. Just some pictures. So crack sealing operations over here again. Specialized material. There's a configuration application. You can see they've routed here. They're doing a nice overband there. And on the filling side, just kind of putting down some material and then sanding over it, calling it a day. Right. Why crack seal? We talked about this a little bit. You guys already know, right? Ultimately, we're trying to protect the base and the sub-base of our roads, right? We want to keep the integrity of that pavement. We want to keep good pavements in good conditions. And we know that when cracks open up, as soon as you get a crack, you're going to have water, you're going to get debris down inside of that crack, and you're going to have, you open up the integrity to allow things to start to degrade the base and sub-base of your pavement. So we want to seal those cracks up, keep all the water and everything out of there, protect that sub-base, okay? This is just a chart that shows, we're all here for the business of pavement preservation, right? We want to preserve our pavements. So this is just a chart that kind of shows the life extension benefits of crack treatments. So along this black line, this would be a regular a pavement if no treatment was conducted. Just looking at an average lifespan of an asphalt pavement. If you didn't do anything to that road, you just build it and let it go. This middle red dotted line here is showing for crack filling operations. So if you would go out and crack fill, be looking at getting, can extend about 2 years service life of that pavement. And then the last red line is for crack sealing. We know you can get about 5 years of service extension of that pavement with crack sealing operations, okay? So it's very cost effective. It tends to be significantly less than other surface treatments under our pavement preservation umbrella. And provides a bunch of different benefits. Again, less money, sometimes less time wasted in traffic, decreased exposure, right, than major construction and rehabilitation projects. Always worry about the safety of our workers and our crews. Smoother ride, just for the motoring public, having a better transit system, less wear and tear on vehicles. They did a bunch of studies on it, and a national average is they say that urban decay, your roadway degradation, costs drivers, that's you and me, right? We all have cars, most of us I assume, right? Costs us about $377 on average a year in wear and tear in our vehicles, just on vehicle maintenance, right? So Want to preserve our roads, keep them in good condition. Everybody feel good so far? That's all the basic stuff. Got the basics out of the way? Feeling good? All right, how's my pace? Am I going too fast, too slow? Good? All right, you guys tell me. So I'm just gonna map off of you, and if we're moving, we're gonna move and groove through it. So this next section, I wanna start talking about crack sealing as a pre-treatment. You see crack sealant used to pre-treat cracks for a lot of different surface treatments out there, okay? We do know that if you treat the cracks with crack sealant prior to your surface treatment, you're going to get better performance of that surface treatment, all right? What I have here is some of the information conducted by NCAT. So that's the National Center for Asphalt Technology. I've gone down there, walked the test track. So this is right from their website. You can go look at all of this yourself. It's at pavetrack.com. So if you want to go online, they have a lot of good information on there. They did a 3-year preservation study. It's still continuing. They're still conducting this study. However, the data I have here is from they initially put down these treatments in 2012, and then they studied all of these test sections, and they came out with their first report in 2015, and they came out with some really great data. Of the different 25 treatments, so what we're looking at is this road here. This is Lee's Road right here, and they did 25 sections, 2 were control sections, and the other 23 sections they put different treatments down. They did crack seals, they did chips, double chip, triple trip, they did micros, slurries, different mix designs, etc. So I'm going to show you the results from here. This is their main test track. There's also, I'm not going to go into that today, but they have a lot of good data there on mixed designs and such, just FYI if you ever want to look into any of that data. And this is their newest treatments that they put down on US 280. They did test sections there as well. So again, this is down in Auburn, Alabama. So you're in a warmer climate. And what they did is they actually went up and they put this same, they are mirroring this Lee Road project that we're going to talk about in a moment. They mirrored that up in Minnesota, and they're going up and they put test treatments. It was at it was just last year, 17 or 16? 16 or 17? 16, 2016. They put the different test treatments down there because they wanted to do an exact comparison of the warm weather climates versus the cold weather climates, because we know that our materials are going to perform differently in different climates and under different stresses. So good data we're looking at to come out of there. So here again, so the 25 sections, this is Lee Road, 159, 5.5 inch thick paved road. The road is, it's like a country road. It's out and it's very out in the country, and it goes up to a stone quarry. So it's interesting in looking at the information as we know that the one on the inbound lane, they're coming in, those trucks are coming in empty, right? And then the outbound lane, they're coming down fully loaded down. So it's interesting to see the differences in those lanes because of the weight differential, because then you have the different load volumes that you have on both sides of that roadway. What they were doing, the purpose of why they did this is they wanted to see what is the lifetime benefit of each of these treatments. So again, I'm going to show you the data that came out in 2015. They're still conducting some more data. They're continuing to test it. And what they're going to do is they're just going to continue to evaluate each of these sections through the lifetime of the treatments. They're basically just going to let them go until they are all completely failed. And then they're going to get a really good look, an analytical look at what is a real lifetime line, if you will, timeline of what kind of benefit you get out of these different types of treatments. So pretty cool data. So in their results, this is the control section. So I'm going to explain the way that these charts look. So again, this I pulled right from their website. This is all of their information from Buzz Powell down there. So what they did is, this is their control sections. They went and they studied it, and that is baseline. That's ground zero, if you will, all right? Every other chart I'm going to show you, what they did is they compared the deterioration of that test section in comparison back to control. Because what they wanted to do is get what is the difference, what is the benefit I'm seeing from this treatment as compared to this control section that we didn't do anything to. Does that make sense? Okay. So this was the section 5. So this was the crack sealing section. That's all they did. They just went in and crack sealed in this one section of the pavement there. Comparing it against the control section. So this was after 2 years of data. And again, I know it's a little bit small, but up here you're at the 1 year mark right here. There was no new cracking. The sealant was performing at 100%. So it was performing at 100% versus control. And then into the second year, again, additional, so good data there. So there was 75% less cracking in comparison to the control section. So good results coming out of there. This is a picture of those sections. If you can see, there's a really faint white line across here. So this section down here in this area is the control section. That's what they didn't do anything to. And you can see all of the cracking that's down in this area here. Above this line, this section is the crack sealed section. You can see, can you see it in the back? I know it might be difficult, but that's where the crack sealed and the sealant was performing there on those cracks. Okay, so again, good results. 100% performance after 1 year, and then 75% performance after 2 years. Had gone through 2 of those weather cycles through the winters. Looking at, this is L6, so this is the chip seal section. In this section, they just came in, they put down a single chip seal. They did not pre-treat with crack sealant. They just came in, blew it off, and put down the chip seal. So at a year, performing good, still 100%. Chip seal's holding up really well. And then you can see as soon as it got into that winter time, about 18 months in, it started cracking and opening up, and it actually was worse and had more cracking than the control section had. So after about 18 months after putting down the chip seal, it had basically 0 value in comparison to the section that had never had a treatment put down at all. Okay. L7, so the section right behind that, and I have a picture of that next too. This section they went in and they crack sealed first, and then they put the chip seal down. And you can see all the way across, 100%. So after year 1, still 100% performance of that chip seal. At year 2, it was still performing at 100%. So that crack sealant was sealing up those cracks underneath, and it was doing its job underneath there and allowing that chip seal to perform the way it needed to perform to protect that entire surface of that road. So in comparison, right, just the monetary, the cost benefit there, if you're going to put the money into that treatment, right, we want to get that life expectancy out of it. So we were looking at complete failure at about 18 months, or after 2 years, it was still performing at 100% just by going and putting some crack sealant down first. Is this surprising to anybody? I'm glad there's a lot of no's. Good. This is a picture of that section. This is an older picture, but so there's a line here, and it might be hard to see. But this is the section that was just chip sealed, and you can see right down that center line that opened up right there already, and you can see there's water in it and everything. And then this section behind it was the section that they came in and crack sealed first and then chipped over top of. You can see it looks good. Don't really see much reflection up back through that chip seal at all. So good results coming out of there. Cost savings for just a little bit more work, a little bit more money, a lot more value benefit out of it. L9, they did a double chip. So they came and did a double layer chip seal. Again, at year 1, we're seeing this to be a trend. That first year, everything performed really good. Everything was still performing at 100%. And then it started cracking open after that winter. Again, it came into that second winter about 18 months in, started cracking. So it was still performing well. So the double chip performed better than the single chip seal. But now you're doubling your expense, though, as well. And you're getting 75%, better performance than the control section. But in comparison, so the crack sealing with the single chip seal performed better than just a double chip seal. So lower cost, better performance. L8, they did a triple chip seal. And then the same thing here. It performed very, very well, but they still got cracking about 95%. So now you're looking, again, additional more cost in a triple chip seal. And it still was outperformed by just crack sealing first on a single chip seal. So looking at microsurfacing, so this section in L11, this was just a microsurface they put down, and you can see the trend here. I'm going to move a little bit faster now that you've seen some of these charts. So year one, great performance, 100%, good micro, didn't crack open at all, and then they started getting into the colder months, and then it started cracking, so about 50% cracking, and then by the end of the second year, there was only 15% less cracking than the control section. So still better than the control section. Got a year to 100%. They got out to about a little over a year, and it was, about 50% performance. And then at the end of year two, only 15% less cracking than that control section. On L12, they crack sealed first, and again, you can see the trend here, 100% performance through that first year. Then some cracking began to form again in those winter months, started getting colder, some cracks started to form. But at the end of those 2 years, there was still 60% less cracking. In comparison to the micro without the crack treatment first as a pre-treatment, was only 15% more performance than the control section. Does that make sense? Am I explaining that clearly? Okay. This is a look at that section. So this, again, here's the line if you can see it. This section here is that micro, just the micro, no crack treatment. And this section behind it was where they crack sealed. You can see a little bit of underneath there. And then the micro on top of it. And there's another look at that one. So this is the micro without crack sealing. And this is the micro with crack sealing. And again, just looking at the benefit difference there with crack sealing as a pre-treatment. So in general, what we're looking at in terms of sealing, hairline up to, so like about 1/8 of an inch, right, up to 1.5 inches. If the crack density is less than 20%, we're going to recommend route and seal. If that crack density is greater than 20%, we wouldn't recommend routing. Look at a blow and go application. It sounds like a lot of you are doing that. Wide cracks, so once your cracks get up over or even close to 1.5 inches or wider, it's too large for crack sealant. We would then be looking at a mastic sealant to seal that crack at that point, those wide cracks. Down here are pictures. These are pictures of our mastic material, so you can see the center line here. It's all raveled out, so they're coming in and using a mastic to seal that wide crack up there. And highway project, this was from up in New York, coming in and routing out those transverse cracks and coming in and sealing with an overband behind it. This is one of many. There's a lot of different PCI charts out there. This is one, and yes, again, I already talked about this a little bit, but when you're getting into really bad, beat up, failed pavements, we are not going to recommend crack sealing. You're not going to get the benefit from it. It's too far gone. You're looking at rehab or reconstruction or mill and fill and other different treatment options at that point if your pavement's that bad. Not surprising to anybody, right? Okay. Wrapping up here, so crack sealing, we talked earlier about the seasonal cycles, right? Typically, we're crack sealing in spring and fall, right? And cracks are all the way open in what season, typically? Winter, and they're all the way closed in what season? Summer. So let's look at winter crack sealing. Summer, we do see a lot of crack sealing in summer. Who here crack seals in the summer, has people out in the summer? Most of us do. A lot of people do, absolutely. This is also a time I would plug for routing, again, especially in those transverse cracks. If your cracks aren't, if they're getting closed up because that pavement's hotter and swelled and those cracks are closing up, that's when you might want to get in there with a router, open that crack up a little bit so you can get enough material in there so that when that seasonal cycle comes back through winter and it opens back up, you don't crack that sealant back open, right? So you might want to look at routing in those types of conditions to extend the life of your sealant there. Winter crack sealing, we've seen some successful winter crack sealing programs in different states up in the northern US. So we've seen it in Minnesota, New York, I think Montana's been doing it. Anyone here from your areas crack sealing in the winter? You're doing everything over there. Yes. So I saw some hands go up. Okay. So can you crack seal in the winter? Sure, because you can crack seal when you can't do a lot of other stuff sometimes. Conditions have to be right, though. If there's snow on the ground, are you crack sealing? Yes. No. Whatever he tells me to do, right? So we want to make sure that there are certain conditions that are in place to recommend winter crack sealing. It's not always appropriate, but if the conditions are ideal, then absolutely. And we've seen some success. The air temperature doesn't matter. Typically what is recommended is what we're looking at is that pavement temperature, okay? We want a minimum of 40 degrees F pavement temperature to crack seal. Minimum 40 F and rising, okay? It obviously gets a lot colder than that in a lot of parts of this country. Reservoirs, so when routing, there are different reservoir configurations, widths and depths. What do you typically do when you're routing? 3/4, 3/4, 3/4, pretty standard. So that's standard. So that would be a standard reservoir. There are deep cuts, not seen as much. And then we see these shallow flush reservoirs that are cut.
A little wider.
Thank you. Wider, shallower reservoirs. These are going to be used in extremely cold climates. So they have seen very good performance of this wide, shallow route. And is it Montana that they're doing this in mostly?
Montana does a lot of it, yeah.
So they're, again, you're looking at extremely cold climates. They're seeing good performance with this type of a reservoir dimension there. Most people are 3/4 inch, 3/4 inch standard reservoir over here, okay? So when routing, get in a reservoir. So that's one of the type of configurations FHWA talks to. And then a combination would be both. You're routing and you have an overband. So you're routing a reservoir and then you're coming in and you're overbanding that, whether that be with the sealing disc or with the squeegee. But a combination configuration, we know in every study has shown, studies have shown that that is the longest performing application. So when you're routing and sealing with an overband, studies have shown you get the greatest sealant life performance out of that type of an application. So yes, it's another piece of equipment. It can be a little bit lengthier of a process, but you're getting years more on your performance. And I have a chart I'll show you here at the end. And we're getting there. You guys are doing good. So here we're sealing with a sealing disc, so you can still see he's putting that overband down on there just with the shoe, not with the squeegee. Following along there on the crack, nice and tight to the pavement. And I like to point out what he did there at the end when he comes to the edge of the cracks. A lot of time, if you have a guy that comes out to the edge of that crack and ends right there at the edge of the roadway, they get a little puddling there at the edge. We don't want to leave a puddle of material at the edge of the roadway there. If you're in colder areas, snow plows, tracking, you can get different issues with it. Just have them come back in, back over that material, level that out, get a nice clean application. Again, the theme you'll hear a lot, quality materials and a quality application are going to give you your best performance. Okay? Nice tight overband there, good application. And so this is from studies showing the different months of life, service life of the sealant based on the type of application that was used. So this was just an overband, a Band-Aid as they call it. They did a standard reservoir, just flush filled it. And then here they did a shallow, that wide shallow reservoir with an overband, and then a standard reservoir with an overband. And so you can see here they got 92.5 and 94.5 months service life out of that material, performance out of that material in comparison to just more of a blow and go or a squeegee operation or the reservoir flush filled. So anyone surprised by that data? Okay. I'm not going to read that, I promise. I'm not going to do that to you. Just in conclusion, this is just kind of in summation of the point we're trying to make. So the SHARP study, the 106 study, is one of the largest crack treatment studies ever conducted. There's a lot of data up here that they're talking to. So they studied a whole bunch of different manufacturers, applications, installations, climates, equipment use. They studied a whole bunch of stuff, a whole bunch of different factors, looking at these different treatment types and seeing what gave them the best performance. And the most important things are in the bottom here. I just wanted to point out is that the study determined that for appropriately designed crack treatments, for pavements in the correct condition range, using correct materials and correct installation methods, they had lanes ranging for up to 10 years and performance was achieved. Okay, so there is a huge importance and correlation between correct materials and the correct application is going to give you a quality product. You're going to get a good treatment and you're going to get the most service life out of it. They also noticed that those that were incorrectly designed or installed wrong, the treatment life could be less than 1 year. That's a whole heck of a waste of money. So again, the right materials, quality workmanship, quality application are going to give you your best service life of your material. Okay?
All right, we're missing a few people, but we're going to get going on this. Going to talk about equipment now. It's kind of the stuff I enjoy. Couple different types of melters out there. We have a non-jacketed or direct fire type melter used on a lot of smaller type projects, little parking lots. The oil jacketed double boiler type melter is really what is used pretty much in the industry. If you're out doing any type of big crack sealing, that's what you're using. Talk a little bit about compressors, reservoir cutting equipment, or routers as we call them. The rotary impact router is probably the most common out there, and that's what we manufacture, and a couple other manufacturers have them. There's also a small diamond saw that's used, and then vacuum systems that are starting to kind of come up now with the OSHA requirements coming along. We'll also talk a little bit about hand tools, the wands, the hoses, the heated and unheated hoses, the types of tips, depending on what your application is. You're going to want to pick the correct tip. Squeegees, hot air lances, and then a maintenance on the equipment for the oil jacketed melters and the routers. So start right out here with the melters for application of hot applied crack sealants. There's a variety of manufacturers, sizes available, different types of fuel sources. Probably the most common is the diesel fired units. Going to have a diesel engine. It's also going to have a diesel burner to create that heat. There are some LP ones out there on the market. And then you get into the different sizes depending on how big you get. This unit here is a Easy 1000. So that's a 264 gallon machine. It's probably mid-range for us. We go all the way up to 400 gallon. We go all the way down to a 50 gallon in a jacketed machine, and then this is a 10 gallon direct fire type machine, again obviously for a small parking lot, that kind of thing. Along with that direct fire type machine, we have a 30 gallon that's out on the market. A couple different manufacturers make these. And these are generally used as a feeder unit that's going to feed the 10 gallon machine. So you can start heating in here, you're applying with that, you're going to pull up, just dump material into that 10 gallon machine and keep right on working. Small direct fire, it's going to have a little LP torch and a gas bottle on it. You can kind of see here the torch goes right up underneath there. it's going to heat that whole thing up. So the whole thing gets really hot. Again, direct fire. It's just heating the steel up. The steel's heating the material up. Got to keep in mind with a direct fire machine, you have to use material that's designed for direct fire pots. If you don't, you're going to put the wrong material in there. You're going to burn up the sealant. It's going to get real stringy. It's going to track. It's going to make a mess. So keep in mind with the direct fire machines, you got to run direct fire type sealant. You also find that it's a little more expensive because it has to be made a certain way. The polymers have to be the right polymers to take all that heat that you're putting into it. Then we get into the oil jacketed machines. This is a small machine here. This is a little 60. Then we get into a 125 here, and this is a 250-gallon machine here. You know, these all are agitated machines. They all are controlled by the electronics to keep the material at a certain temperature for you, keep it agitating. All four of these machines are all electrically heated hoses, so you don't have to heat them up in an oven box, get them going, get the pump working. Very easy to run. A couple different manufacturers out there that make these type of machines. Again, variety of sizes, 50 gallon to 400 gallons. Most all of them are towable units. There are some skid mounted units available that you can put on the back of a truck. They do have gravity feed options. This right here is a little gravity feed going into just a small pour pot that you just drag around. It's not heated, so you have to work very quickly, move around to fill the cracks. Over here is the electrically heated wand and hose here. So it heats it all up. It'll get that hose and wand up to 380 degrees. So the material's going to flow out at temperature for you. This one also has an on-demand trigger system. So there's no flow in that hose until you pull the trigger. It's going to activate the pump. It's going to start pumping material for you. Very safe machine when you're running like that. 50-gallon machine, gravity feed, we just talked about it. This one has a 400 gallon per hour melt rate. So it's not bad for a small parking lot. This one here happens to be a rotary vane compressor. There's no tank with it. It's a 100% duty cycle machine. These will go up to 100 CFM at 90 PSI, so you're delivering a lot of air, and it does a very good job to clean out the cracks. Not a lot of maintenance to these machines. Checking the oil. You got, can't see it there. No, where is it? You can't see it in this picture. It's behind the hose there. There's a little sight gauge. It's got one little filter in it to change out and stuff, so it's a real easy compressor to deal with. So again, as we were talking, you want to clean out these cracks very well. You can see him blowing the dirt out. Again, they're blowing away from the traffic, so they're blowing it off to the edge of the road here, going that way, so you're not blowing dirt and debris up against a car going by. The routers, also used for cleaning and widening the cracks. This is what's called an impact router. Inside this hub right here is this part of the mechanism, and it holds 6 of these star-type blades. So that wheel goes around, and then the blades will turn with it, and that's what's creating that grinding effect or that impact that's going to go in there and clean that out. A lot of times you want to go in on the wider cracks to just dress up the edges if they're wide. If you've got a lot of deterioration on the inside of that crack, I had a gentleman ask me about that on break. So you'd use that router to run down the sides of a wider crack, or we're going to show you here in a minute, you can add more blades and offset them, and that router will actually route up to 1.5 inches wide. So if you're doing those big, wide, shallow routes, you can do it in one pass with this router. This router here will generally give you a production of 600 to 800 lineal foot per hour. Again, the operators kind of have to learn how to do that. It's kind of a finesse thing. You can't manhandle this machine. You got to learn how to just let it work, and it will do a very nice job for you. It follows the cracks very well. It's very maneuverable. You have a depth control on there, so you can adjust the depth as you need it. And then there's several different routers out on the market. Just a standard router. We have a new dust control router that's going to contain the dust, and then a self-propelled router, and then that's also made in the dust control type router also. Again, yes, do we have a question? Oh, okay, sorry. You can kind of see here just real quick, you can see right where they ran that vacuum and that cleaned that all out. You can see a little bit of dirt that was left from the router. So anyway, on this slide, we're talking a little bit showing the different application tools, the swivel discs, and then we're going to talk about squeegees also. Oh, and then we're going to talk about hoses, variety of hoses. This one here is a standard hose. It's used in the old style machines where you have the oven box in the back. You have to heat the hose up, get it up around 300 degrees, get the material flowing through it. This one here is a heated hose, so it doesn't have to be racked inside the unit like that. It'll heat internally. Several different manufacturers out there making both types. And again, can be used on several different machines. The wands, standard wand on a heated hose there. Your electrical goes in here. Your sealant hose hooks up right there, and then it just flows down. Got a trigger there. This one, the trigger's right there. Just pull the trigger. Again, it's going to activate the pump. You just have a flow of material. The different wand tips can be used. The straight tip generally is used for deeper application where you're trying to get that sealant down inside that crack. The auto anti-drip tip generally is used if you're squeegeeing, you're just putting the material right on the top of the surface. Not as desirable because you want to get that material down in that crack. Couple different types of sealing shoes. The nice thing with this is you're right over your crack and you're pushing that material down inside there, and then it's also leaving you a band without having to run a squeegee behind it. So you can eliminate a squeegee guy. So those are very desirable. This is an old style metal tip. You're actually just kind of filling this area here up and you're just dragging it over the top of the crack. It's just going to run into it. And then a couple of the elongated tips. We see a lot of that used with concrete joint sealing where they've got good straight joints that they've made. They can run that tip either down in it, or this one actually has a little bit of a shoe on it. Just set it down and just bring it right across the top of the concrete, and it's going to fill that joint up. Squeegees, couple different types on the market. Some with a really heavy rubber on it. This one here is the heavier rubber ones. They also make the silicone ones. I like those because they're a little more pliable. You can get a little more pressure down. Problem is they wear a little bit quicker, so depending on what kind of asphalt you're working on, you might choose a heavier rubber one versus the silicone one. A couple different pictures there. This one actually, they've got a disc and they're also running the squeegee over it. Same with that one there. That one's a little bit wide. If you're going to do an overlay, I don't know that I would run it quite that wide. This one, more than likely, they're just going to open it to traffic, so it's not as critical. of having a little bit wider overband. Hot air lances, we've talked a lot about that already. Pretty nice piece of equipment when you're in an area that's got a lot of moisture, cooler air, and you need to heat that up. You have to be very careful. They do put out in excess of 2100 degree heated air, superheated air. The nice thing with this is that air is heated in that chamber and you're not getting any flames on the asphalt. So you're not going to deteriorate the asphalt as easy. You still can do it, but it's not as easy. Again, talked about drying the crack out, softening and warming up the pavement. They do come with little wheel kits and a little debris shield because it can blow some stuff back at you. You do have to be careful if you're getting the pavement a little too dark. You're probably overheating the pavement and you're going to distress that pavement. It's not good for it. So you have to be careful with that. If it starts smoking, you're cooking that oil out of that pavement. So again, have to be very, very careful with that.
Speed talking commence, okay. This section is more about sealant selection. There is no secret sauce. There is no one sealant fits all. It's just not a reality. There are a lot of different factors that influence the type of sealant you use. If it's spec material, that's obviously the first thing you have to look for. If it's a spec material, you got to be in spec. And then all these other things we'll talk about, the types, the properties of a sealant, why they're important and what they do. Climate conditions, pavement conditions, installation, configuration, all of these things factor into your sealant selection, all right? I'm gonna try to move quickly, so please stop me if I'm going too quickly and let me know if you have questions along the way, just shout them on out. So we'll look at specs, properties, climate conditions, and then installation configurations. So looking at specs, some of the most common are going to be your ASTM specs, so your American Society for Testing and Materials. It's a standardization, right? Excuse me, so that you get consistency across the industry with how materials are tested and what standards they need to meet. The one thing I always like to point out with these specs when we're looking at ASTM specs, a spec material is, there's a lot of them. There's a lot of different types of material that can meet the same spec. The spec is the minimum requirement. It's not the gold ring. It's not saying that that's the most fantastic stuff in the world. It's saying it has to at least do this to qualify. Does that make sense? That's the bare minimum, because there's a lot of different types of materials from different manufacturers that will meet the same spec. Point being, a lot of different specs out there. The three I'm really going to talk about, and then we'll move on. So D5329, a material will not meet D5329. So ASTM D5329, that is how the testing is to be conducted. That's for the labs. So that's kind of the set of rules on how they conduct the testing appropriately. That helps us as an industry get consistency with testing results. And if something goes to this lab over here and goes to this lab over here, I sure as heck want to hope that you're both getting the same exact results on that material, right? So that's what 5329 is. A material will not meet that. That is the standards for how the labs test the material, okay? 6690, who here's heard of D6690? No one? Yep, so this is going to be your most common. So D6690, there's type 1, 2, 3, and 4. I'm not going to go into a whole ton of detail on the differences there. Brian, will you pass this board around for me? We brought some samples out. We had them at our booth earlier, so you can see the fingerprints where everyone's poking and prodding on them. I'll get into it a little bit later, but in a nutshell, you can feel the difference in material. Again, not all sealants are the same. We ourselves, again, we manufacture close to 100 different types of sealants. So every manufacturer manufactures a bunch of them, okay? There's different climates they're going to be used in, different properties that you want to have in these sealants. So there's a whole bunch out there. But 6690, type 1, 2, 3, and 4, in a nutshell, the main difference are going to be the low temperature properties. I have a chart I'll show you later, because you're looking at that low temperature flexibility, how cold a material can get and still maintain its flexibility without cracking open. And when you stick your finger in that, you'll feel the difference in the stiffness and softness of those materials, okay? Who comes from hot climates? Okay, hot weather people, do you use a really stiff material or a really soft material? Stiff, why? Yeah, if it's soft and mushy to start with and it gets hot, it's gonna melt all over the place. You're gonna have a mess, right? Where's our cold weather guys? Where are my cold weather peeps, right? Now, do you use a softer material or a stiffer material? Softer, why? Because it gets cold and you need it to still flex and move with those cracks in the wintertime when it gets really cold and those cracks are still opening up, right? You don't want that material to crack open. It has to maintain flexibility and elongation in low temperatures. So all of these things are engineered, right? Sealants, I always say, are like making a cake. There's a recipe for it. There's so much flour, so much sugar, right? You get all kinds of different flavors and consistencies because all the ingredients get tweaked a little bit. That's what engineers do, right? They're always tweaking the formulations and you get a different end product based on the types of ingredients you put in. You have a question? You want it in the middle? I can just use it kind of all the time. So that's, I can't give you an in the middle sealant. And Malibu. And I do have a chart I'm going to show you up here. There's some resources you can go to. And again, in the essence of time, if you do have questions, you can talk to Brian, talk to your local manufacturer's reps. They'll be able to help educate you and talk you through different sealant offerings, their properties, the specs they meet, and help make recommendations to you on if you're using the right sealant or not. So absolutely have those conversations. Make sure you're using the right material.
We will talk a little bit more on Thursday when we go through the mix table. We'll have a table set up. We'll talk a little bit more about the design of sealants, what makes them more flexible, and where you would use some and not in others. So we'll go over that a little on Thursday.
Yeah, because you have like the polymers and the oils and everything, you'll show them. So you'll be able to see all the different ingredients that go in and what they do and how they make those sealants different. But good question. I don't have a regular though for you. All right, so 6690, 5078. So this spec is for the spec for crack filler. So the main difference, so looking at them in a nutshell, this is how you conduct the tests. This tells the labs how to do the tests. 6690 is the spec for crack sealant. 5078 is for crack filler, okay? So different types of specs are out there, that's the main point. There's a separate one for like silicone materials and such, right? So different types of specs exist out there. And again, agencies can have their own specs, states, cities. There's some other unique things when you're in parking lot situations. That question came up earlier. If you have high pedestrian traffic, wheel turning, foot traffic, you're definitely going to want to look at a parking lot sealant, which is a much stiffer material designed to withstand those stresses. High slope, right? If you have really high sloped, we get into race car tracks and such when they have extreme slopes. They need specialized materials to seal their joints and cracks there. Direct fired sealants for those smaller units or direct fire machines. Brian mentioned earlier that when you have direct fire units, direct fire sealants are typically more expensive because they are designed to withstand that direct heat coming at them, right? So be very careful to make sure that you're using the right sealant and the right type of melter. Because if you don't use a direct fire sealant in one of those little mini melters or such, you can burn that material up and burn the properties out of that material and degrade its effectiveness, okay? All right, so point there's a lot of different specs out there. If you have a spec material for your job, it's a spec job, that's the first thing you need to look at in determining what sealant you use. It needs to meet the spec, okay? Second thing we're going to look at here are other factors. We know that sealants are going to be subjected to a ton of different stresses depending on where you're at in the country. But we know they're all going to have that expansion and contraction, that movement from the weather. They're going to have different traffic loadings, exposure to rain, snow, abrasion from street sweeping and snow plows, all kinds of different things, right? And you put a material down, you want it to do its job for as long as possible. You want to have a quality material, put down a quality application, because ultimately you want it to be preserving that pavement and you want to extend that service life of that pavement. So you want your sealant material to last. It has to be able to withstand some of these things though, which is why you need to know what is in your area and what your sealant is going to be subjected to again, help you select the right sealant. Here's a list of 9 different types of tests, if you will, that are done. The top 5 are the ones I'm going to talk about today. A lot of times the specs kind of revolve mostly around these 5 areas: adhesion, your high temperature stability, your low temperature flexibility properties, elasticity, and viscosity. Obviously there's other tests out there: aging resistance, curing, pot life, compatibility with asphalt. That's kind of important, right? So we're going to focus on these next 5 though here. The bond test is probably one of they're all important, but the bond test is going to be important. Your sealant needs to stick to the pavement. You need it to adhere, you need it to stick, you want it to stay, all right? So we do these bond tests. It's a little sample of material is bound between 2 concrete blocks. Even the concrete blocks are spec'd and cut and designed a certain way, again, for consistency in testing. They'll run them through at different temperatures, different cycles, extending them out and everything, pulling them out until they fail. They fail when they either break adhesively or cohesively, right? So adhesive, they're going to physically, the sealant will rip off one of the blocks. Cohesive, it'll stay stuck to both blocks, but the sealant material itself will rip and tear apart, okay? So that's what the bond test is. Different temperatures, different numbers of cycles they put it through. They want to make sure it sticks to the pavement, okay? Tensile adhesion, also similar, wants to see the elongation capabilities of a sealant, so this is run as well. Why are these important? Again, because you want your material to stick. This isn't really bad, but this would be an adhesive failure. You can see there's some cracking here. That material's pulling away from the crack faces there. This is cohesive failure. It's still stuck to the crack, it's still adhering well, but the material itself cracked open, all right? Making sure you have the right material for your area is going to make sure that you prevent these different types of failures. Ways to help with that, some troubleshooting tips. Some of these things are items we've talked about already. Sometimes it just comes down to the material was installed the wrong way. It wasn't clean enough, it was too dirty, it was too wet. You're going to have adhesion issues. If you have a dirty crack or a wet crack, it's going to pull out, okay? The pavement temperature was too cold. Got to be at a minimum of 40F, absolutely. If it's a weak, it's just a bad pavement, you might have a failure there. If you're resealing a crack that has old sealant in it, you want to clean out that old material. Again, clean and dry is always important. You just don't want to go in and seal up over old degraded sealant in that crack. Can run into adhesion issues there. And again, incorrect application. The most common one is application temperature. You want to make sure your material is at the right temperature when you're putting it down. If it's not hot enough, you're going to have adhesion issues. You need that material to be at the right temperature to make sure you get the right bond and the right adhesion to the pavement there, okay? So that's to whoever said 325 application temperature early today. Other things to avoid it. So again, clean and dry, hot air lamps to get it up to 40. Use a compressor, with a moisture and an oil trap. You want to make sure that you aren't blowing oil or water. You get condensation from that compressed air. You don't want to be blowing water and oil back into that crack. You're trying to clean it and dry it out. A lot of times you'll kind of just hold it against a piece of cardboard and just shoot it and make sure there's no oil or water spitting out of there. But those oil and moisture traps help prevent that. Again, remove old sealant. Make sure you're at the right application temperatures. Reheat your material only to the manufacturer's instructions. This happens when we get bad weather. You go out, you heat your material up, you're ready to go to work, starts to rain, you shut it down. Go back out the next day, you heat it up, rain, you shut it down. A lot of times you're ruining that material now, okay? Because there's a pot life on all of your material. Kind of a standard is 12 to 15 hours pot life. Every time you add more material though, that helps you reset that clock on that pot life. So every time you're putting fresh material in, to your hot kettle, you're resetting that hot life clock. It's when you're just letting that material sit there and heat and heat and heat and heat, and then you shut down, you heat it back up again, that's when you're going to run into some issues. Okay? Anyone ever run into that? You can get stringing, gelling. You're gonna, one of the biggest things you can do if you overheat your material or reheat it too many times, if it's a polymer modified material, you can burn out the properties of those polymers or those rubbers in that material, and it's not gonna perform the way it's expected to. You can have viscosity issues. I have a nice picture of a big mess of material on the ground.
That's the technical.
That is the technical term. It's like a big lump of, so you can run into some issues there. So, softening point. So this one's also very important. We do this is a ring and ball apparatus, so we do a softening point test. What we're doing is we're measuring that sealant material sample and we're heating it until it turns from a solid to a viscous liquid, okay? Basically, there's these little balls that sit here on the sealant sample. We heat them up, and whenever that material gets so soft that those balls drop down through the material, that's the softening point. Does that make sense? Okay. So Brian mentioned it earlier, kind of a standard softening point on most materials is 176. But if it's at 176, typically that means it can be heated up to about 185, 190. It's good for kind of like a reservoir application. Here, if you're doing an overband application, those require we recommend a higher minimum softening point because there's more exposure to traffic and UV and such. So we want to make sure that the material you're using in an overband application, you want it to be able to have at least 45 degrees higher softening point than what that pavement temperature is going to be. What does that mean? Here's an example. I'm from Phoenix. It gets hot there, very, very hot. So our pavement temperatures can get up to 145, 150. It's pretty toasty. So our material has to have a softening point at least 45 degrees higher than that to ensure it doesn't start tracking. So we're looking for materials with the softening point of about 200 to 210. Does that make sense? Right? Colder areas, a minimum softening should be probably like 160, 170 will be ideal if you're in a cold climate area, okay? It's more so those hot areas where we're worried about that softening point. You wanna make sure everywhere that you have the right high temperature stability properties of your sealant. Tracking can be an issue and it's messy, like this. So where's this at, Brian? I believe this was one of yours. Brian didn't do this personally.
That was in Phoenix, outside of high school. Kind of two issues on that one. They put the wrong sealant in, and then that left turn lane was opened up right away for cars sitting to go into a high school to pick up kids, and it was a mess. So it's real easy to do that if you're not watching what you're doing.
So that's what happens if you don't have a high enough softening point of your material. You get a big mess on your hands, okay? So that's what tracking is, so that's why softening point is important. Want to make sure you're at least 45 degrees higher on your softening point of your material than the hottest that pavement gets, okay? How to avoid tracking? More isn't always better with sealant, okay? This picture here, this is excessive. There's a lot of sealant here. A couple of you on break were showing me. And I know we all chuckle about it because we see it, just ridiculous pictures with material all over the place. More isn't always better. Don't open it up to traffic too soon. Make sure it has a chance to cure a little bit and solidify. You can use detacking products. There's sprays and materials out there. We manufacture some. Sand, the application of lime or like 30 mesh sand or something, you can dust on it. Helps that tack, so you can open it to traffic a little bit more quickly. If you pick the incorrect sealant, or if you over or underheat your material, again, the importance of that application temperature. Make sure you're reaching those application ranges from your manufacturer. Stay within there. No thicker than 3 millimeters, 1/8 of an inch. Brian just mentioned that as well. So no thicker than 1/8 of an inch on your overbands. Make sure it's cooled before you open it to traffic. Use a DTAC. Make sure weather conditions are right. Reheat only as indicated by the manufacturer. Everybody still with me? Am I going too fast? Are we okay? We're good? Okay. Slopes. Pavement conditions, high moving cracks. Again, you want a quality product, especially when you're anticipating movement. Other things that will influence what type of sealant you get, I touched on this a little bit earlier, is your melter type. If you have a small little unit, direct fire, you need direct fire material, okay? Cleaning methods, what are you doing on your preparation for your crack treatments? What kind of installation are you performing? Contractor experience, experience of the crew. All of these things come into play, as well as traffic conditions.
All right, so we're going to go through construction best practices, reservoir cutting, crack cleaning, proper sealant, heating, maintaining your melter temperatures, finishing, weather conditions, personnel. Personnel requirements, safety procedures, traffic control, cleanup, a lot of stuff you guys already know. We're going to touch on it just a bit. So reservoir cutting. We always want to do these transverse cracks. We've talked about that. Straight uniform cutting is good. Production, we talked about that a little bit. Here's a good example. This is a nice clean cut on that reservoir. This one here, obviously the blades are spalling a little bit. It's probably not deep enough either. So kind of a bad, inappropriate reservoir there. Again, talking about cutting. Obviously, you always want to read your operation instructions. Want to wear your PPE. These machines put out a lot of dust, a lot of rock. Want to make sure you got eyeglasses on, you've got work boots, long pants, shirt, all that. Always want to make sure you go through the machine, check it, make sure it's ready to go. Get the router head up out of the asphalt, get it up to speed before you drop it into the asphalt. You always want to route from your center line or away from your traffic. Anybody that's ran a router, you guys know, anybody that's ran a router, if that thing starts to go on you, it will push you right into traffic. So just good practice. Always route away from your traffic so you're not getting pushed into the traffic. Cutting your reservoir. You want to produce an equal center cut over the crack. If you got a big wide crack, we talked about this, taking at least an 1/8 inch off each side of the crack. Cold weather, we talked about this, using a little bit wider reservoirs if you need to in the colder weather. Stop if you're getting excessive spalling. Right here you can see this asphalt here is probably very old and brittle, and it's starting to pull it apart. You're getting a lot of extra cracking. You're doing more damage than good. So you're gonna want to stop routing on this. You don't want to keep routing that. Cleaning cracks, obviously not a very well cleaned crack there. This is good and clean. Using compressed air or a vacuum in conjunction with compressed air, hot air lance or wire brushing to clean those out. We talked about it, clean and dry. You got to have it to make the sealant work. Cleaning with compressed air, you're going to blow out the debris, the dirt, the weeds. Again, you want to blow it away from the traffic, not towards the traffic. Also want to be mindful of your co-workers working around you. You don't want to be blowing it towards them. Make sure you've got the right pressure and velocity going. And then we're going to talk and show you the finger test, making sure you got your sealant clean or your joint clean enough. So here you can see he's blowing it out away from the traffic. You see his finger right there? He ran it down through there. See how dirty that is? Just think about that. You put sealant in there like that, it's going to stick to the dirt. It's not going to stick to the crack. More than likely, that sealant's going to fail and pull right up out of there. Same thing with moisture. If it was that moist in there, the sealant's not going to cure against the asphalt. You're going to be able to grab it and just pull it right out. Oh, here we go, that one's working. A lot of dirt in that crack there. If you didn't get that cleaned out, that sealant's not going to stick. So again, that's why you got to clean those cracks out to get that sealant to stick. This is the head on one of the vacuum systems here. Again, these 3 air nozzles blow the air down in, get the dirt clean, moving around, and then it's sucked up through the hose there. A little video on this. You hear that air blowing out there. Again, this is set up on a truck, so he's cleaning right in front of the truck. They're sealing right behind, so it doesn't slow the system down at all. He can move as fast as the rest of the crew moves. You can see how much dirt he's taken out of that when he's going down through there. And you can see how clean that is right around where that head goes. A little bit of dirt on the sides that were left from the router. And again, right down that edge joint there. You see how clean that gets down in there. See how much dirt's in that crack there? All right. So using a hot air lance, again, you're just wanting to warm up that asphalt, get it cleaned out. It's going to do 2 things. It'll actually blow the dirt and stuff that's in there out of there, then clean it up. Moist climates, if you've got a dew point that's up high overnight, you got dew in the road. A lot of times we'll see the road's good, and then all of a sudden you come around the curve and there's a bunch of trees, shade on the asphalt. You probably got moisture laying in there. And, you know, again, you may have to dig it out and get that cleaned out. Nighttime crack sealing, when your dew points get down too low, that's when you're going to want to see or use a hot air lance to get that warmed up. We talked a little bit about this, slight darkening of the pavement. These type of hot air lances are indirect, so you're not putting flame on the asphalt, so you're not deteriorating the asphalt. If you're starting to see smoke coming out of the asphalt, then you probably are moving too slowly. You are starting to degrade the asphalt, so you need to move a little bit quicker. And then we talked a little bit about the excessive bubbling of the sealant. Could mean that you need to get it a little drier. It needs to be used, have a hot air lance used on it. Wire brush machines, talked a little bit about that. You can run them down through there. It helps dig out some of the heavier compacted stuff, maybe even pull out some of the weeds and stuff you'll see. Proper sealant heating, very important. Again, make sure you're reading the manufacturer's installation guide on sealant. You should be adding blocks of material as you're using the machine. So if you're going down the road and you put down 3 gallons or so of material, I always like to time it about every 5 minutes. You should be putting a block of material into that machine. That keeps it refreshed, keeps it working. If you just take off and start running for an hour and you don't put any material in that machine, you've just sucked all that good hot material out, and you're going to have to stop and put 20 blocks in. It's going to take a half an hour or so to get that material warmed back up and ready to go. So you always want to be feeding whatever you put on the ground. You should be putting a block of material into the machine. Proper sealant heating. Again, most of the machines nowadays are electronically controlled. You set the dials, it's going to give you a digital readout. It's going to maintain that heat for you. All you got to do is load it. It's going to take care of itself for you. Melter agitation, very important. Always want to make sure that agitation is going. It keeps your blocks melting. It also keeps the material from getting scorched laying against the side of the machine. And then depending on if it's a high rubber content in the material or a fiber content, it's also going to keep all that material suspended, keep it well mixed. All right, so that was the end of that knowledge check, kind of the end of our session here. Brandy and I will be around the next couple of days. We'll be at the booth. We're also going to have the demo tomorrow and then the mix table on Thursday. So if you got any other questions, feel free to get a hold of us.